Hello, geometry students. This is an extra review, and this is not the practice test. You already did the practice test, but this is an extra review. And so this is a chance to have some more practice identifying which of these particular ratios you should use, sine, cosine, or tangent. So let's take a look and see what we can discover from this. So this is matches up with number 1 on your review packet. And as you can see, you've been asked to find a side length. Okay, so what about that side length? Let's take a look at it. Here it is right here. So we have 3 things here, 2 of them known, 1 of them unknown. So what are our knowns? We have a 35-degree angle, and we have a hypotenuse that's 40 centimeters long. So let's examine that. It's the hypotenuse that is one of our knowns. Therefore, we have to use either sine or cosine. And so we look at where the angle is, and we see that the side across from it here is not a part of our 3 pieces of information. The one that is adjacent to it is, and remember that that's cosine. So let's take a look at how we would set that up. We're going to do the cosine of 35 equals x over 40, adjacent over hypotenuse. Okay. So then what? Then we will multiply both sides by 40, giving us this equation here. Cosine of 35 times 40. I actually prefer 40 times the cosine of 35. Just because you run into fewer calculator problems when you do. 32.8. Oops, let's go back. All right, on your calculator, let's take a look at that. Here's our calculator. So we were doing 40 times the cosine of 35. So let's try that. We can do that on this one. 40 times the cosine of 35. And it tells us it is 32.76, which rounds up to 32.8. All right, so there you have it, 32.8 for that one. All right, let's go on to number 2. That was cosine. So again, remember 3 pieces of information. We look at what is the 2 known pieces and what is the 3rd piece. Okay, so here we have an isosceles right triangle, and 2 sides are exactly the same. So don't go through a lot of decision making on this. You know from lesson 11.3 on special triangles that the hypotenuse, which they're asking us to find here, is the square root of 2 times one of the legs in an isosceles right triangle. So don't make harder work of it than it is. 3.5 times the square root of 2, 4.9 inches. And I will not be going to the calculator for that. I think you all know how to do that on a calculator. Okay, so now notice here that we do not have a right triangle. So that should be a clue to you that we have to go with our 11.7 law of sines and law of cosines. So that's a little bit different than the rest of the chapter is. So I'm finding these in alphabetical order. So I'm going to find x first, and then y, and then z. All right. Now, to use law of sines, I would need to know one of the angle measures, and I don't know any of the angle measures. So I have to use law of cosines. So remember that when we are trying to find an angle measure, that these 2 pieces have to begin and end that long law of cosines equation. So here you have c squared equals a squared plus b squared minus 2ab times cosine c. Now in this case, when we're trying to find an angle, that's going to be our variable right there at the end. So I'm going to fill in, I'll put in 30 squared equals 34 squared plus 41 squared minus 2 times 34 times 41 times cosine of x. Cosine of, it's actually of angle D, but it's x degrees, so we can go ahead and use that variable in there. All right, now this is the math. Now we've been over enough examples of this that I'm not gonna go ahead and do all those steps. You know, you got to add these two together and you see what you get then. So subtracting from both sides, 2,837. So I get this. Negative 1,937 equals negative 2,788 times cosine of x. All right, so this is about 0.695, right? So that's the cosine of x. So now I have to go to the calculator and do second cosine. We'll discard that. Second cosine, 0.695. I'll go to this one for that, clear that. Second cosine, 0.695. And what does that equal? 45.97, so that rounds to the nearest whole degree, 46 degrees, as you can see on the slide right here, 46 degrees. Okay. Those are the first three. So at least we're partly done. Now we have to get to the here. So we got 46 degrees here. And now we want to find y next. So since we could use law of cosines again, but since we now have an angle measure, we can also use law of sines. So we're going to find y using law of sines. All right, so what do you have here? You've got the sine of 46 over 30. So again, remember, law of sines match opposite angle with the opposite side over the one that we're trying to find, sine of y over its opposite side, 41. So cross multiply, and that gives us 41 times the sine of 46 equals 30 times the sine of y. So dividing both sides by 30, these got a little bit off. That's supposed to be canceling that out. This should be a little further over, but anyway, you get the idea. Okay, so that gives us this math. So 41, and I'm going to do this on the calculator, 41 times the sine of 46 divided by 30 equals this, 0.983. And then when we put that in to the calculator, we're going to find out it equals 79 degrees. Let's go to the calculator and do those steps here. Discard those and get the calculator back. And what we have here on the calculator, let's clear that. All right, so this is where we have to go with the calculator. What the 41 times the sine of 46. All right, so 41 and sine of 46. And remember, we said we have to close parentheses and then divide by 30. And it gave us that 0.983. That's where that came from. We did this math in the calculator. Now we're not done. We have to find the angle measure. We found the actual ratio. Now we have to find the angle measure. All right, so we need let's clear that first. We need the inverse of the sine. So 0.983. It tells us it's 79 degrees, which you can see right here. All right, so you're almost done with this. So we have the simplest task left. So let's bring us back up to this point. So I have a 79-degree angle here. So then I just subtract those two known angles from the 180, and I find out that z equals 55. All right, that's the first page. I hope that went well for you. See you on page 2.